let's talk about going beyond the basics. Like I just showed you, this demo works. It's very easy to set up. It's got a lot of cool potential. But how do we handle things like in the real world, like multiple servers, authentication? What happens when your application finally takes off and you're the new Twitter or something like that? How are you going to handle the complexity that comes along with that? There's a couple of things we're going to talk about that, and I think it'll become clear to you. So one of my recommendations for if you think your project would benefit from WebSockets and you think that it's going to grow past any level of complexity, I would strongly encourage you to consider how STOMP works, to learn about that and see if it's right for you. It is a little bit more complicated to set up, but we've got a blog post about that, and it's going to help solve a lot of those problems for you, or at least give you a framework for how to solve them up front. So I would really encourage you to look into that. We'll do a quick overview of that here. So STOMP stands for Simple Text-Oriented Messaging Protocol. And without STOMP, you have to solve all of these problems for yourself. Message format and serialization, whatever your protocol is going to be, like, in the examples we looked at, we were just sending a simple text string like click or hello or whatever. And that can work great for a little bit, but then it can get really hairy later on. It also, sometimes you might run into a situation where you have a lot of clients connected to a server and you want the clients to be able to kind of communicate with each other. And maybe the server doesn't really care what they're saying to one another. It's just transient data that it's great if you have it, but it's also okay if it gets lost or something like that. Well, if you haven't used STOMP, you have to actually go in and manage and touch all of that data to get it where it needs to go. But STOMP has a really interesting topic subscription and routing framework, refers to as exchanges, which we'll look at. It also provides you a really simple way to implement authentication and authorization through a couple of listeners in your WebSocket BX. And then it also handles automatic reconnect and a health check, heartbeat kind of messaging thing to make sure that your client is still connected. So basically, STOMP is easier to implement than stick in later. It would be a refactor more than an upgrade. Yeah, I would definitely agree with that. I mean, if you end up skipping STOMP early and then having to refactor, and then your application grows in complexity and you want to refactor to it, I think that could be a really big headache. And it could, especially if you don't have like automated testing or something like that, you might miss edge cases. I think for me, it really boils down to STOMP is kind of in that category where it looks like more trouble than it's worth at first, to be totally honest. But the learning curve, once you get over that, you spend a couple of hours reading the spec and understanding it, it becomes clear, and then it's kind of a no-brainer at that point. So I would really encourage people who are considering it to just take the deep dive, get the learning over with, and then reap the benefits down the road. You can kind of think of it as a pub sublayer on top of raw WebSockets. So let's look at security and STOMP. The first thing I want you to notice is that we are no longer extending the WebSocket core class. We are extending WebSocketSTOMP, which in turn extends WebSocket core. So you're going to still be getting access to all of the things you had in WebSocket core, but you're going to get extra things with WebSocketSTOMP to help with that, to help with implementing and conforming to the STOMP standard. And so there's a couple of functions here that are going to be added to that. The first one is authenticate. When the client connects to your STOMP server, they have the ability to pass through some credentials. Now, you can get the credentials out of the request, which is where login and passcode will come from, or you can also get access to cookies here. So if you're doing session-based authentication, you have access to the cookie scope, and you can look at their token that way. And then here you can just check some things like, this is just a hard-coded login equals admin, passcode equals secret. Please don't implement this pattern, but I think you can understand where we're going with this. You could get out the value and check it against your database. You could hash it. It could be a signed JWT. That you verify first. You can do any number of things here. The most important part is just that you return true or false. And then we have an authorize function. This is called specifically when a client attempts to listen to or create a subscription to a STOMP exchange. Now, we'll cover some of those topics a little bit in more detail in just a moment, but the idea is a client has requested a specific exchange. The information of the client will be sent along, and then specifically the exchange that they want to listen to will be here. And then you can use that to decide if they're authorized. So a quick example would be, maybe you have your exchanges set up with something like some sort of naming convention. Like you have admin events, which would be like admin orders, admin logged in users, admin dot whatever, right? And then you could have user level exchanges, which are like user dot job counts, user dot job completed notification, whatever. So when a user tries to subscribe to an exchange, you could check and see, okay, are they an admin? Then we're going to let them go for, it doesn't matter what the channel is named or the exchange is named. We're just going to let them listen to everything. Then someone else tries to connect and we check the database and find out that their user is not an admin. They are just a regular user of the system. If we then see that they're trying to connect to an exchange called user job completed notification, then we go ahead and we return true because they're allowed to listen to those ones. If they try to connect to a different exchange that is prefixed with admin dot, then we would say, oh, hold on, you're just a regular user. You're trying to connect to an admin exchange. We're going to return false in that circumstance. So you can see it's a pretty easy thing to implement here. Another function I want to draw attention to in when you're implementing this, or when you're extending this class, WebSocketSTOMP, you'll get authenticate, authorize, but you'll also have access to something called configure. When you override this function, you can provide a configuration struct that tells your STOMP broker how to behave. There's a lot of configuration that you can put into this. I'm only going to draw your attention to it, and I'm going to tell you about exchanges. If you want to know more about this, I would encourage you to read the blog post, as well as to go and read the SocketBox documentation where it actually covers this. You can find that on ForgeBox. But basically, the important part here is that when you're working with STOMP, you need to configure your exchanges and your subscriptions. Exchanges, you can kind of think of them like mailboxes. And I hear this, a lot of people use this analogy of STOMP being like a mailroom in like a big office building or something like that. And so an exchange would be kind of like a mailbox. And when mail comes in, it first goes to a mailbox in the mailroom. And then it's after that an office mail person will go to that mailbox, see that it has a message, and then they'll think about the rules for that mailbox before they distribute it. So that allows you to do some kind of convenient things. Like here, if something goes to the direct exchange, then you can have it go to other exchanges. So this is basically just like simple alias routing. Topic allows you to use wildcards. Like here, the pound is a wildcard. So you could orders dot whatever would match both orders dot shipped and orders dot canceled. Fan out allows you to create like a one-to-many exchange where it comes in on one thing and then it gets sent out to multiple other ones. And then this distribution one, I'm sorry, it's hard to read here, but it's basically like a round robin thing. So you can have, if you're going to exchange A and that's set up as a distribution, then it could do a round robin forwarding to like destination B, C, and D in order. Okay, now let's also talk about subscriptions. This is something that was actually a little bit confusing to me. So hopefully by drawing attention to it, it'll make it easier on you guys when you're implementing this in your application. But in the world of STOMP, they have worked really hard to completely abstract the routing of messages. And I kind of had this assumption that the server gets to listen to every message that goes through, but that's not actually the case. In STOMP, your server is treated almost like just a regular client. So your server has to actually subscribe to a message if it cares about processing it. On one hand, that's really weird and kind of made me uncomfortable the first time I was implementing it. But then I realized that that's actually really convenient because you can network all of your different exchanges together very easily just with some configuration. And then you can set up the server to only listen to and care about the actual data that it wants to process. And that's very simple. So in your subscriptions, you just put the name of the event or of the message that you want to listen to, and then you throw in a closure here to be able to respond to that message. So very easy to implement, but like I said, a little bit extra boilerplate. Now, another thing I'll kind of point out is that this can make it a little bit confusing to know how to send a message to a specific user, but that's where kind of getting creative with your exchanges can help out with that. So if you want to, like what I've done in previous applications is I'll create a topic exchange and then I'll have like user dot and then the user ID, right? So we'll actually have dynamic topics that can be listened to and broadcast to. And then that way, if user 5 tries to listen to user.6 events, then they won't be authorized to do that. I'll check that in the authorization handler and reject them. And then whenever I want to send a message to, user 9, maybe their records are ready for viewing or something like that, then I can just broadcast to the topic user.9. whatever, and be confident that only user with ID 9 will get that information. But the other great part of that is, if you remember, I mentioned that you can get a WebSocket connection for every tab that you have open. Well, if user 9 has 15 tabs open, you can just target them categorically using that subscription and exchange model. And that's where there's a little bit of a learning curve. But like I said, it pays dividends later on in your application's scaling. So highly recommend that.